I'm Ashrith. I'm a security scientist at H2o. And firstly, thanks for staying so long. I know this is the penultimate talk. I hope I don't disappoint you. So let's start with that. Quick question. How many of you guys have used H2o here? Okay, quite a few. How many of you out here work in the field of fraud, AML? Oh, wait, right. Okay. So I'm sure you probably have seen displays out there which briefly spoke about what the talk's going to be. So today's talk's going to be about AML, which is H2o designing solutions for anti-money laundering. And I'm actually a security scientist at H2o. I dabble in two areas. One is cybersecurity and in financial fraud. So my specialization is actually in the area of anomalous behavior detection. So that kind of works out for all these things. So what are we going to talk today? I'll give you a brief idea of what AML is, how it occurs, and we'll go about talking to you about the solution that we are trying to provide to different financial organizations across the globe.
Hello.
This will be
Hey, how's it going? How's it going? Blah, 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 blah,
how many of you guys deal with financial regulators all the time?
Hello.
Okay, that's a pretty decent number out here. So, and the reason, in a few moments, you'll actually know why I'm asking that question. So, what is money laundering? So, money laundering is basically, just having illegal sources for money, and then you take the same money and put it into legitimate sources, and then you want to position it as a valid source of money. So you have three different processes that actually come in money laundering. One is called placement, which is actually bringing in the ill-gotten money into the system. Then the next thing is layering, which is basically disconnecting the source of the money to the place where you placed it. Sometimes what you do here is you send your money to shell accounts, shell companies, bank accounts overseas that do not have traces, banks that claim to be, in certain islands where it's literally a box and a mailbox, which seems very interesting for most of the things that I deal with. And so that's the layering process. The final process is actually integration. Integration is when the money actually comes back to your account. So mind you, if let's say I'm dealing in drugs, probably I wouldn't make big money in Seattle, but if I was dealing in drugs and then I got a lot of money, what I would do is I would try and send it through some kind of a channel which tells me that they'll wash the money for me, and then they'll send it back into my account with, of course, 20% cut because of the process that they have to go through. That's usually the fair way that money laundering actually happens. And most of the sources are ill-gotten. It's gambling, human trafficking. Actually, human trafficking is one of the biggest ways of, getting illegal money. I'm not sure how many of you guys are aware. It's a big deal between Asia and Europe, because there's a land border, so a lot of human trafficking happens. A lot of money crosses hands out there. So we tend to deal with a lot of European clients as well, who are situated, between Eurasia and stuff like that, because that's one of the spots where a lot of money, handoff actually happens. So, I told you about how money laundering happens, but it should be okay for it to exist, right? I mean, it's just another process. It's not necessarily affecting people. That's not exactly true. Money laundering actually affects society, the globe itself in different ways. You have like parallel markets. It impacts the society in a very big way. So, quick question out here. How many of you guys think, copying a CD is all right? Okay. That's the ideal answer, but I'm sure, many of you would want to raise their hands, but yeah. So, piracy is one of the big ways as well that contributes to money laundering, if you guys didn't know. And so what happens is parallel economies come up, it impacts society. Not all the time. There are some countries which are actually in such a bad state, in such a poor state. Piracy actually helps them get educated, which so that's probably one place, where you'd be on the fence to say, is piracy a good thing or a bad thing? And so governments tend to lose out taxes. In some countries, the amount of money that's held by illegitimate sources are so big that they actually end up bringing out parallel economies. So that's actually a big problem. So quick question, do we have a solution for it? Yes. There are lots of companies that are actually working to solving money laundering, but most of them right now are actually rule-based. You have some of the best companies, like Actimize, FCRM. They're some of the best solutions that exist in the world right now. But much of them are rule-based, and they don't necessarily track state. State is where you can connect if a source of money to how it got through to where it ended up. So the initial 3 steps that I told you about, where it's placement of money, layering of money, and then integration of the money back into the system. If you can track these things, then you're more stateful. Sorry. So what is the solution that? So I mean, the fact that these solutions. Sorry. The fact that these solutions are limited. So what is the next thing that we do? I'm sure this is an ML conference, so everybody would answer saying that we would use machine learning or AI for this. So yes, that is what we do. We provide solutions using machine learning and AI for identifying money laundering. But there is a set of complex problems that you come up with. When you provide these solutions, so you actually have to go through a lot of regulation. And the reason why is when you provide these solutions, the regulator would like to understand how your algorithm works, why it's classifying something as a false positive or something as a false negative. Why is a certain transaction not necessarily classified as a money laundering when it could be a very typical money laundering situation. Now, that brings in certain limitations for people like us who actually design these algorithms. One of the things is I can't just take the data and jump into some crazy super learner ensemble model which has got amazing number of trees and you just can't decipher from it. So you can't do those kind of things. You have to start very simple. And when I say simple, it'll be like 25 trees, random forest, depth of 5 is something how you start off with. And I know a lot of people might say, oh, that's just stupid, let's just go with the big guns. Unfortunately, you can't do that because of how regulators look at this data. So that's some of the limitations of the field. But of course, we're working through it. H2o provides model interpretation as well, along with the models. So that's something that we're supporting most of our clients, so that's kind of helpful. The next set of slides that I'm actually going to show you is how an analyst using the rule-based system goes through money laundering situations. So this is how the system is. System was in the past, or you can say system is largely existing right now, currently. So, and this is the solution that we prescribe, where basically from a rule-based system we go to a feature-based system, which is purely like a tree-based model, and then we are looking at pure data-driven model, without which could be any kind of deep learning process or any other kind of modeling where we necessarily do not require all the data sources that we use for the feature. So this is the current day design. So you have alerts that actually come in through different feeds. You have alerts which basically say, oh, this transaction seems suspicious. Can you please analyze this, is how the current system spits out. And what happens is there is an analyst, a human investigator, who looks at the alert, and then he brings in, accounts information, transactional information, your credit card information, different, how are you placed legally? Are you at a risk of committing fraud? Are you at a risk of committing a crime? They look at your LexisNexis information, to figure out whether you had a bad history or, you've been a good citizen all the while and stuff like that. And based off all these things, they actually decide whether an alert is suspicious or not suspicious. So the moment we bring in a human being, there is always a subjective judgment that actually comes in. So some of the limitations of this system. Give me a second. Let's see if this comes back. Yeah. So some of the limitations of the system is the process is manual. You're looking at data sources from different. You're looking at data from different sources, not necessarily integrated, not necessarily compacted together, and it's very subjective and inconsistent. And the problem is it's super time consuming. So we did an analysis about sitting with investigators, and we found out that the minimum time an investigator takes to actually clear an alert is 40 minutes. Sometimes it can go up to 2 hours in one sitting. Sometimes the alerts have to go through multiple people in terms of how good they are, in terms of their experience, and it takes 3 months to clear an alert. That's an amazingly long process considering that they see 6,000 alerts a day. And the government wants you to do more. So we definitely have to provide a solution out there. The one other big problem with this solution, with the rule-based solution, is super high false positive rate. Anyone want to take a guess at what is the false positive rate in this area? Just a guess. Not going to judge you guys, please.
92%.
Wow. Okay. Okay. Yeah. I know you worked in finance. Yeah. So yes. Some of the best false positives. When I say best, I mean reducing the false positives. The best we've got is like 80% in rule-based systems. The worst actually is 100%. So everything is false. So we've had that problems as well. Now, so that kind of gives you, so that makes the problem interesting as well as approachable, because you can solve a big part of this problem. So what we propose, one of the first things that we propose to make sure that the regulators are convinced and the bank is convinced and people understand the process. And what happens is the regulators tend to actually work with the investigators. So someone from a regulation team actually has to go sit with the investigators and say, explain to me why this thing made a decision in a certain way. So the way we design models is actually based off a random forest model, and we give them a complete understanding of how the model makes its decision. So for that model, we design a feature-based approach in this case. The way we look at this is we look at data as basically providing us information. It's like metadata, which is actually providing information for the algorithm. And you can assume you can kind of understand that the metadata that we extract is something like a language where the algorithm and the data are trying to speak to each other. So that kind of helps in capturing information. So if you were to look at pure transactions could be looked at as textual data. Now you need to structure the transactional data or the alert data in a certain way that you can capture all the information that's available. And some of the, most of our energies that we do at, for these solutions are actually focused on designing features that actually make a lot of sense and they add a lot of value to the algorithm. I would actually say like 90% of our times is feature development, and the 10% of our times is when we do algorithmic tuning and trying to use some minimal ensemble techniques and stuff like that. And yeah. So the sources of data that we use for an analysis is basically transactions of payments, the accounts information, and the alerts. So in this case, we actually use the alerts to train our model. The alerts are the ones that these existing systems spit out, and they say whether these things are a suspicious or a potentially suspicious alert or not. They might not necessarily be true because these systems are purely working off a rule where they say, oh, within 7 days if you do a transaction of about $10,000, flag it. That's it, straightforward. So we use that. Now, the next question might come up where you say, how are you labeling these things? So what we do is we actually send these alerts to the investigators to actually label them for us. So they will be able to explore this and identify these alerts and say, this is a valid transaction, this is a valid alert, this is not necessarily a valid alert and such. So we use that as labeling for our analysis. So some of the ways in which we develop features. The anomalous behavioral design that I do are largely focused on time and time series based of analysis. So most of the features that I design in any of the fields tend to focus on how behaviors vary or don't vary across time. So time is a very key component that I use in my analysis. If you actually look at the thing here, so we're looking at, this is just an example feature that I've put out. So we're looking at an average balance for the last 7 days. And the way we do it is we're calculating average balance for every day, or sometimes we do it even after every transaction. So the advantage with this is that instead of having an end of the day balance, which is purely like one data point or one discrete, one part of a signal, when you calculate average balance, it's actually encoding, your balance for the last 7 days into one signal, and then it's giving you a lot more valid data. Now, a similar feature could also be average balance for the last 15 days, or 30 days, or 60 days, and depending on the kind of frequency that you want to look at. The one other thing that we also look at is how many transactions, how many withdrawals occur per day, or how many, what is the average rate of withdrawal, what is the average rate of deposit, what is the average amount of withdrawal divided by the average amount of, average number of withdrawals. So those are the kind of features that actually help us identify identify behavior. And you might say, why do you want to track this, every day for the last 7 days? Well, the interesting aspect comes here, is that, so if you were to look at a rule-based system, then you would be able to identify, any, potentially malicious behavior by one occurrence. So if the transaction broke a certain threshold, only then does the rule-based system actually capture it. Now, with the kind of feature design that we do, the advantage is that any spike of this kind is actually broken down across these averages, across time and stuff like that. So so the intensity of the signal is actually higher because you have more amount of data points that reinforce at the algorithm and say, hey, there is a spike here, look at this behavior. There is a spike here, look at this behavior. So you're statistically reinforcing the system. You're saying there is more data points to look at. So that kind of helps you identify the behavior. And the advantages with these things is that you are actually able to track the transactions directly. So any change, any variation in the transaction is in itself a signal. So in this case, so let's say you didn't design these features, then your signal or your data point would purely be the columns that that came from your database table. Now, if you were to design this, your signal could also be the deltas between these different values. So I could calculate what my balance is today, and I could calculate what my balance is tomorrow, and the delta of which could actually give me, another signal. So these are kind of data points that actually help us identify new behavior. So after putting the design into implementation, the way the system works is the H2o algorithm actually ingests transactions, accounts, and card data, and then it ingests the alerts as well. So it's able to join all these things together and then run it through the algorithm, and then we are accurately able to identify if it's suspicious or not suspicious. In our best tests, we were close to about 95% accurate in identifying false positives. In our worst tests, we were able to identify about 79% of the false positives. So I know 79 to 95 is kind of a broad range, but I think the fact that we cut down in our worst case, we cut down the false positives by about 64% is kind of a good thing for the bank, considering the amount of manpower they actually spend on solving these alerts. It's actually a pretty big reduction that we kind of saw. So, which is why quite a few banks actually take these implementation very seriously. So, what are the advantages of this? One, it's not subjective anymore. It's very accurate. It's very consistent, and the classification is very quick. The positive rate is actually pretty low. So the other thing about the false positive rate is it also depends on your risk appetite. You need to know, how much risk you can take. And when I say the risk appetite, it means that what is the amount of false positives, or what is the percentage of false positives or the percentage of false negatives that you can take. We have some financial institutions who want a false negative rate close to, actually less than 1%. So we have to tune the algorithm, for their needs. There are some financial institutions who are all right to take their, false negative rate to about 3%. So we can tune them to tune the algorithms for them, at that rate. So that kind of varies based off your risk appetite. It depends on how much you want to accept, how much you don't want to. And sometimes what happens is this is also a negotiation, with the regulators, where you say, this is how good our algorithm is. This is how good we are classifying what we think are actually malicious. So although we are keeping our false negative rate high, look at the fact that we are classifying true AML at a really high level. There are some, there are people with different ideas in the industry where they say, you know what, the government doesn't care about how accurate my alerts are, so all I'll do is any transaction that even remotely looks suspicious, I'll just pack it up and file it as suspicious. Now, that's basically, that's not necessarily a bad way to do it, but there are no smarts in that algorithm. All you're trying to do is you're just trying to pack out any transaction that looks suspicious and just send it out. So yeah, that's just limited in that sense. So one of the other features that we also provide is we also provide the capability of an investigator to analyze the data. So the investigator is able to interact with the model, pick out a sample set, and then analyze and see how how good the prediction is. So based off that, so there is some amount of model tuning that we do. So if the investigator actually provides a new set of values, then the model gets retrained and then it gets redeployed. I think quite a few people might have a question about how how we did the labeling or how we did the model verification. Because that too can end up being very, very biased. If we have a bunch of investigators in one location, in one office and in one financial institution, that could be super biased. So one of the things that we did is we chose investigators from different levels of experience, different geographical locations, different operational times and stuff like that, just to make sure that they don't necessarily have the same kind of bias in the data. And that actually helped us pretty well, because when we look at geographically similar data set, the biases tend to be very close. So that's one information. So the next level is the next thing that we're actually working on right now is a pure data-driven model, and we're trying to do we're trying to use some amount of deep learning that we've recently designed into this model. And the idea with this model is that we don't use the alerts data anymore. We should be in a position where we can truly discover anomalous behavior. At least I should be justifiable to what I do. So true anomalous behavior should exist somewhere. So what we're trying to do is we're trying to ignore the alert data and try to pick up signals from the transactions and the cards and the accounts information, to be able to predict if a certain transaction is suspicious or not. And this currently is purely for money laundering, but this also can be integrated with a certain other set that we do, is where identifying fraudulent transactions. So AML and fraudulent are kind of a different space. Fraudulent tends to be more real-time, more discrete in its operation, while AML tends to be more long-term kind of an operation. So with this model, you can kind of integrate those two and bring them together. So that's something that we're looking forward, next installment of working with, money laundering and stuff. So the idea here is that the data can speak for itself, and it can make sense. So I think I'm probably run out of my time. So any questions? Anything at all? Yes. So in this case, so the question was, when you're dealing with regulators, is a black box model worth it? Is that, would that? Oh, okay, that's actually a great question. Because you're absolutely right. No, we can't deploy this at this point in time because the regulators would not accept a black box. But the idea here is that we parallelly are starting to develop model interpretation as well, which we feel by the time we are ready to deploy a deep learning approach, the model interpretation would very successfully help us in explaining the model using like a surrogate model, like a loco or a k-lime or something like that is our approach. Yeah.
Can this be applied for Bitcoin transactions?
We haven't tried it, but I believe that would be probably a great use case to look at. Okay. Yeah.
Do you foresee times in the future when regulators will accept a black box model?
I would not. I do not, but you never know. Times might change. Any other questions? Are we good? Thank you.